So as we start chapter 7, we're talking about systems of linear equations. We've done a lot of work with linear equations. Now we're going to be talking about something called systems of linear equations. And so the question that I gave you here to start off with was this one right here. It says this: a school district has buses that carry 12 passengers and buses that carry 24 passengers. The total passenger capacity is 780. So this means that we have 780 students that need to go on these buses. There also needs to be some of each kind of bus, and more specifically, there should be 20 more smaller buses than larger ones. So the question here is, right, the question is saying, how many of each bus would we need to carry all the students? And also to have 20 more smaller buses. So I gave you a few minutes to try this, and if you're watching this video, you can pause this and try and attempt this on your own. But we're going to go over the answer here in a few seconds. And at this point, all you need to try is just basically trial and error, use your intuition, run some possibilities, right, of the different number of buses. So the important part is there's two major parts to this question, okay? And the two major parts are these. We have to have 780 students, and they have to come in these buses that carry 12 and 24 passengers. But they're also, the second part, there's got to be 20 more smaller buses than larger ones. So if we talk about small buses and large buses, all right, what are the possible combinations? Let's just run a few, all right? Small buses. Okay, we have to have 20 more small buses than large ones, and we have to get this many students in them. So I'm just going to randomly pick like 25 and 5. Okay? Again, randomly pick. Let's see how many students would fit in these buses. And I'm going to write this out kind of like as an equation. So I want to know if I have small buses that carry 12, so there's 25 of them here, and they have 12 people in each. I'm going to add that with the 5 buses that carry 24 people each, right? And this is going to be the number of people. So let's just give this one a try. Okay, so you can get your calculator out if you need to. 25 times 12 is 300. Okay, so that's 300 kids in those buses. Everyone see that? And then we're going to add 5 times 24. Okay, 5 times 24, and that's 120. Okay. So what's 300 and 120? That equals 420. So is that the number of students I need to accommodate? No. So I definitely need more buses. So I'm going to up these numbers, but what I have to keep in mind is that there needs to be a difference of 20. So let's go to 30 and 10. Okay, let's try that. Well, what's 30 times 12? 30 times 12. And what is 10 times 24? Right? We need to check that out. So 30 times 12, well, I won't do it on the calculator. You just have to trust me. It's 360. Okay? And 10 times 24 is 240. So what do we get there? We get 600. Oh, we're getting close. Okay? What I want you to understand is that I am actually considering in this, I'm considering two equations. I'm considering two equations. The equations that add up the number of passengers times the number of buses, right? Times the number of buses, to get the number of students, which is 7 equals 780. So this is what I'm trying to find. This is what I'm trying to find. I'm trying to find 12 times some number of small buses plus 24 passengers each times some number of large buses has to equal 780. Do you guys understand that this is what we're trying to look for? Okay? But we're also considering the fact that there has to be 20 more small buses than large ones. So as far as the small buses, if we make an equation out of that, okay, small buses is not the same as large buses, but there has to be 20 more small buses. So guess what? In order for these to be equal, there's more of the small buses. So in order to make an equation, I'm going to add 20 to the smaller number. Okay? This one's a bit tricky. The second equation there is a little bit tricky. First one's easy. Second one's a bit tricky. But that's really what we're considering, right? So look at the large number of buses plus 20 has to equal the small buses. That's what I've been doing. Plus 20 here has to equal, you see that? So that's set up as an equation there. Now, what is the actual answer? Some of you got your hands up there. What would you get? 35 and 15, if I heard you correctly. That is absolutely true. If we plug these numbers in to 35 here and 15, you would get 780. And the difference between 35 and 15 is 20. Okay? Very good, very good. Now, that's you guys used sort of trial and error and a little intuition to solve this. Now I'm going to show you, all right, how to go straight to the equations. So we're going to forget about the trial and error part, which is an okay place to start, but the whole idea of this section and of this chapter is to make equations to kind of be a little bit more efficient with this. So actually I'm just going to get rid of this for now. Okay? So I already talked about these equations, and of course I'm just going to go over this just real quickly one more time. But in these types of questions, you're going to be asked to create two equations for the two separate parts. The first part, 12 times the small buses, right here, plus 24 times the number of large buses should give us 780. So this is the first equation. The second part is a second equation between the small buses and large buses, and notice, I guess the first thing I should mention is that the variables in the question are what we're looking for. How many of each bus, right? So that's the variable I'm going to choose. I'm going to choose one variable for the small bus, one variable for the large bus, okay? All right, I actually, on this next page, I broke this down a little bit for you, okay? So here's the breakdown of it. A system of linear equations involves two or more linear equations describing a complex problem. You should probably write this down to your notes, okay? A system of linear equations involves two or more, and we're just going to focus on two in this course, two linear equations describing a complex problem. So take a second to write that down, as this is the definition of a system of linear equations. All right, so the first thing we have to do, and we kind of skipped ahead to the equations, but really the first thing we have to do is identify the unknown quantities in the question. So when the question says, how many of each bus do we need? That's what we're focusing on for our variables, okay? So small buses and large buses are what we're looking for. And usually what you do is you let the quantities equal variables. So we'll set the small buses to some variable, and it's always a good idea to let that variable be representative of what you're looking for. So small buses I would let equal S, and large buses I would let equal L, okay? Just so when you're going through the question, and most importantly at the end of the question, you know what you've got. So S equals whatever, right? And you know what S is. So that's the first thing we do, is we identify the quantities and we give them a variable. So then we're going to start to make equations, which is kind of, what we've already taken a look at. So an equation that relates the variables together, you're going to make two of those. And so the first one usually comes from the first half of the question. So the first sentence usually contains the information that you need to create the first equation. All right. So let's break this down a little bit again. So there are 12 passengers for every small bus. So the total number of students that would go in all of the small buses would be 12 times the number of small buses. There's 24 kids can fit in the large buses. So we would say 24 times the number of large buses would be all those kids. If we add them together, we get the total number of students. And so this is where this equation comes from. The first equation is 12S plus 24L equals 780. Okay? Does everyone see where that came from? Because it's going to be your job to look at the wording of the question and to create an equation. So it's important that you see where I got this from. Yes? Anything you need to ask me about? All right. Okay, so the second equation comes from the leftover information. So the second part of the question usually talks about the second equation. There are 20 more small buses than large buses. Okay, so I went over this in the previous page with you. If we need to make an equation relating small buses and large buses, you could do it a number of different ways, okay? But this is what I usually teach. This is how I start it. Put the S on one side, L on the other side of the equation. And if it's just a simple difference thing, or one is more than the other, then what you have to do is you have to figure out which side of the equation this would go on. 20 more, okay? So something is going to be either plus 20 or something is going to be minus 20 to make them equal. So again, here's an equation. So if you have a large number of something and you have a small number of something else, in order to make them equal, you would either have to subtract the difference from the large one to make them equal, or you would have to add to the small one to make them equal. Does that make sense? So 20 more small buses than large buses. Did you see that the small buses are actually the larger amount? Okay, so we can either add 20 to the fewer number of buses, that's L, or we can subtract 20 from whichever one is the larger one. Now I apologize that L and S represent large and small, because this is actually the smaller number of buses, right? So just how that worked out. But this is the smaller number of buses. Plus L, what am I doing? I apologize. I was thinking of something different. So this should be minus 20, okay? So you could do the small buses, there's more of them, so you subtract 20 to make them equal to the number of L buses. Does that make sense? So this one is the larger number, smaller number of buses, okay? So that means you could use this equation, or you could use this equation, or you could do S equals L plus 20. So any one of those three equations would work for the second part. All right? Any questions there? So this is what you're going to have to, that's the biggest thing right now. And again, in 7.1, this is what we're doing, creating these systems. Okay? So this is now the system of equations. You've got these two equations, and you're trying to find numbers that fit in for S and L for both equations at the same time. Right? And we figured out, by trial and error and a little bit of intuition, and what makes sense to us, we're just going to throw some numbers out there and test them. That this one was 35, I guess, 35 buses, and this one was it 15, right? So that works here, and it also works for this equation. So if it works for both equations, that's your answer. Those are your answers. So S equals 35 and L equals 15 for this question, because it satisfies both equations, or it meets the criteria of both of the parts of the question. Okay? So just to finish it up here, again, these are my notes from last time, so they've already kind of been created, a little bit messy. But that's what we're doing in 7.1. We're creating a system of equations, and then we're basically guessing on the solutions, okay? And I will teach you in the next few sections how to algebraically and graphically solve this. Okay? So here's some trial and error that didn't work, right? So okay. Any questions that you guys have for me right now? Any questions? Because we'll do another example or two here for sure, but I want to know if you have any questions here. Okay. Yeah. Go ahead and finish. Okay, so example 1 in your textbook looks like this. So let's put this into practice, okay? So the question says, create a linear system to model this situation. Okay, so here is the situation. This is the situation right here. Let's focus on this. The perimeter of a Nunavut flag is 16 feet. Now, perimeter, if you remember, perimeter is the distance all the way around. You go all the way around, and that length would be the perimeter. Okay? The second part of the question says its length is 2 feet longer than its width. So here is the length, and here is the width. You see that? So there's two major parts of this question. We need to come up with two equations. One for the first part, one for the second part. What are the variables that we're going to use? And I kind of already give you a hint here, right? It kind of makes sense because the question says, what does the question say? Oh, it doesn't actually say here, does it? Basically, we're looking for what is the length and what is the width, okay, that fit this criteria. So let's let L equal length of the flag and W equal width. And when you're doing this, you do need to write this out, especially when you're doing this. Okay, let's think about the test, okay? You need to communicate with me exactly what you're thinking, and you need to show, you know, what everything means, okay? So it's kind of like you're explaining this to someone that wouldn't know what they're doing. So that's a good frame of reference. That's a good idea to do that. Make sure you're very clear on what you're doing. So L is length, W is width. Okay. So let's focus on the first one here. The perimeter of a Nunavut flag is 16 feet. Okay. So how do you get the perimeter of something? Well, you go the distance around, or you add up the length twice, and then you add up the width twice. So perimeter, which actually is 16 feet, is equal to length plus width plus length plus width. Now, can I simplify that equation? You sure can. I'm actually going to put the number on the right side. It doesn't really matter, but I have two L's here, and I have two W's here. And those equal 16. Okay? So the perimeter is 16. So that's what I've come up with. That's my first equation. Everyone see how I got that? That's exactly from this first part there. We good? All right. Okay, so the second part, let's do the second part in blue. Its length is 2 feet longer than its width. Which one's bigger? The length is bigger. So if I'm going to make my second equation, and I'm going to equate length and width, I'm going to use those in an equation, the length is longer. So I have to add 2 to the smaller one. Or I have to subtract 2 from the larger one in order to make them equal. So I'm going to go width plus 2. And I usually like adding over subtracting. Just with subtracting, I don't know, sometimes there's more mistakes that can happen when you have a minus than a plus. I don't know, right? So I usually try to add to the smaller side. So that's a good hint, I think, for you guys. Okay, so there are our two equations. Awesome, awesome. That's A. Any questions about the A? So B says this. Denise has determined that the Nunavut flag is 5 feet long and 3 feet wide. Use the linear system from part A to verify or to check to see if Denise is correct. So this is what we do. If you remember from our example before, right, we have to pick a solution and check to see that it fits both equations at the same time. So that's what we're going to do. We're going to use, let's say that 5 is L and 3 is W. So let's see here. I'm going to use a different color. Use this blue one. So 2 times the length she said was 5 plus 2 times the width she said was 3. So we're going to see if that equals 16. 2 times 5 is 10. 2 times 3 is 6. Does that equal 16? Yes. 10 plus 6 equals 16. So that's good for equation 1. Let's see if it works for equation 2. 5 is length, 3 is width. Look at that. 5 equals 5. It works for equation 2 as well. So we can say Denise is correct. Length equals 5, width equals 3. And there's our work to show. We've plugged both of those into each of the equations. Questions there? Pretty easy? Okay. So there's going to be some more practice for you in the, we'll do some more examples here, but that's the explanation. There's one example there from your textbook.